Hello everyone, in this session we are going to deal about the transmission media and some connecting devices in your networks. So what do you mean by transmission medium? As I told you already, when you send a data from a source to a destination, an intermediate person, which means that your transmission medium takes your data to the destination. So in that kind, let us look into some of the transmission medium which are present in your networks. So first one will be your guided transmission medium. So your transmission is categorized into two, that is, one is the guided and one is the unguided medium. So guided in the sense it is wired. So this wired is restricted to some physical limits. So this unguided in the sense wireless, which doesn't have any restrictions in their limits. So first we'll look into the guided transmission medium. So in this guided transmission medium, the first one will be your twisted pair cable. So this one will be the example of your twisted pair cable, which is nothing but your LAN cable. So if you see here, the wires are in terms of the twisted formats. So we have some 4 set of wiring which are twisted. So this is known as a twisted pair cable. The example is your LAN, the wires used for connecting your LAN. So in that you can see there is a golden wire here. So that one is a conductor and the other one will be your insulators. So these are all the insulators covering the inner conductor. So this we call it as a RJ45. So you can categorize this transmission medium, that is your twisted pair cable, into two types, that is your unshielded twisted pair and a shielded twisted pair. So most commonly used the twisted pair cable is that RJ45, which is nothing but your LAN cable. So here one set of wire supports the transmission, one is for the receiving the signals, and the other things are of no use and it is simply grounded. So most priorly we use only unshielded twisted pair. So in the shielded twisted pair, the difference is the sense you will have some metallic shield in between your covering. Able to see this one? So this one will be the difference between the both. So we prefer unshielded twisted pair in this criteria. So next is one. So next transmission media is your coaxial cable. So the main difference is that this coaxial cable has a higher frequency ranges than your twisted pair cables. So there the twisted pairs are like, it was like twisted. Here we have only one part, that is the inner core, which are surrounded by the other materials. So this one is an example for your coaxial cable, which is nothing but your TV cable. So if you look into it, so this central part will be your inner conductor. So next it will be an insulator and next it will be an outer shield. So this is your coaxial cable, which is mainly used in your TV cables. So this is the diagram of this, and this one will be the core part, and next comes the cladding, which means the outer cover, and this one is for strengthening this particular part, and later you will have some outer jacket. So if you are able to notice here, this one will be your core part and around that a plastic buffer will be there, and next you will have some strength. This is called a Kelver for strength, for strengthening this core part, and outer is your outer jacket, which is just the covering. So the next one is your fiber optic cable. So here your fiber optic cable is made up of either glass or a plastic, which transmits your signal in form of the light. So when you see this, this is the formation of your fiber optic cable. So here you have two parts, that is your core and cladding. So core forms the inner strength of your optic fiber cable, whereas your cladding is just the outer covering of this particular core. So whenever the light the light signal is transmitted from the sender side, so that light is travelled through this core part only, not the cladding, and it finally reaches the receiver. So seeing this fiber optic cable, there is the propagation methods through which your light waves get transmitted. So in that category, the first one will be multimode step index. So if you look into this diagram, so this one will be your cladding part and this one will be your core part. So from the source, the waves gets transmitted and finally it reaches the receiver. So what happens, this density of the core, it remains constant from your center to the edge. So I have mentioned here about the density, and what happens next, the beam of light coming from the source travels in a straight line. So you can look into this, and here we have some distractions here. So this is a way in which your light waves get propagated in terms of a step index. So next category is a multimode graded index. So the same applies here, but there is a lot of distractions, that is, you call it as refractions. The light beam doesn't travel straight and it refracts. So here you don't have such distortions. So this multimode graded index decreases the distortion of the signal. So look at this, it is just one single wave that goes smoothly and it reaches the destination. The next one is your single mode index. So comparing to the diameter of the core mentioned in the multimode index, here the density is smaller and it limits only the beam in a small range. So this is the single mode. So these are all the ways in which your light waves get propagated through your optic fiber cable. So this is all about your guided media, that is your wired media. So next, coming to the unguided media, that is wireless thing. So we have three broad categories in that, which is your radio wave, microwave and infrared waves. So the frequency differs for each and every wave involved here. So in this also we have some propagation methods where your electromagnetic waves propagate through your air, that is the upper level above the earth. So first one will be your ground wave propagation. So ground wave propagation. So this ground wave, it is of low frequency signal, which means that the electromagnetic waves traveling across here, it should consider only the low frequency signals. So you can notice that when this is the earth level, so it travels parallel to the ground. So when it is of low frequency, it travels parallel to the ground. So the restriction of this, that is the frequency restriction of this, will be between few kilohertz to some 5 megahertz. Fine. So the next one will be your skywave propagation. So if you look into this diagram, this one will be my earth level. Yes, so my antennas will reside here. So above the earth level, you have a portion called ionosphere. So this ionosphere may differ in the kilometers from the earth level. So some parts I can have within the reach of 60 to 67 kilometers, and some I can have the reach of 100 kilometers, or it might go above. So whenever the electromagnetic waves from the sender antenna goes and hits the ionosphere, yes, so it can go through any level of the extension. So that is, it is the above the earth level it can be propagated. So you can look here. So it refers to the sky level. Next one will be your line of sight propagation. So this one will be my earth level. Yes. So here I have a sending antenna and here I have a receiver's antenna. So your light signal is traveled in a direct path from your source to destination. So whenever your signal is traveling from a source to destination, there must not be any obstacles here. The obstacles here will observe whatever you are sending. So there should never be any obstacle when your signal is traveling in a line of sight. So the frequency range, it can be below some 40 megahertz. So when you look into this, so your radio wave and microwave are the same, but since the radio wave's frequency range is higher, it is impossible for this radio wave to propagate in the sky. So this microwave is easier in terms of propagation. So when you take the infrared rays, so that is your line of sight. So you can take, for example, your TV remote directly with the TV. So if there is any obstacles here, doesn't change anything in the TV. Yes, right. So same, this is example for your infrared waves. So this is all about your transmission medium used in a network. So next we'll move on to the connecting devices which are used in a network. Connecting devices. So under that you have networking devices and internetworking devices. So under networking devices you have hub, repeater and bridges. So under internetworking devices you have router and gateways. So first we will look into hub. So this hub connects your segments of LAN. It is mainly used in LAN segments. Next, it has some multiple ports. The ports connected to this hub. So how many ever computers can be connected to this hub? So whenever a packet transfers in your hub connected computers, so if one packet transfers from one computer, the connected computers in the hub will receive those packets. There is no limit of what is the destination. It simply reaches all the computers connected to your hub. Next one is it acts as a central connection. So as I mentioned the before case. So next, so because of this one, whenever the computers are sending lot many data packets, so there occurs a network traffic, a lot of confusion takes place and there will be a collision in sending the packet. So in this hub, we categorize them into two. That one is active hub as well as your passive hub. So active hub, it manages the traffic, whereas your passive hub, it gives way for the collision that is happening in general. So the active hub will be the efficient one. So next, the repeaters. So moving on to the repeaters, I can tell that it replicates the signal. So whenever the data is arriving from the upper layer in terms of bits, so the strength of those bits might be weakened. I mean, it can go weak. So what this repeater does is, it will strengthen that bits and it gives the original strength to the bits. That is, it regenerates the bit coming from the sender side, and upon strengthening that, so it gives through the transmission media to the receiver. So the main purpose of this repeater is to regenerate the weakened signals. So next, so like hub, it doesn't have filtering capacity. So it accepts all the data packets going through the port of the repeaters. So you can also extend the physical LAN connectivity. Through the repeaters. If at all you want to extend your physical connection, you can make use of the repeaters. So your next one will be bridges. So telling about the bridges, so each and every devices, that is the disadvantages in the hub, is somewhat overcome by the repeaters, and this repeaters is overcome by the device bridge. So first one is that, so this hub is used in a physical layer of your model, and this repeater is used in your physical level as well. So this bridges is used in your physical level as well as in your data link level layer. So at the physical level, it regenerates the signal. So at the data link layer, so it checks the frames, whether the frame contains the physical address in the packet. So this in turn has the filtering capacity. So how it will check for the filtering capacity in the sense, it possesses a table called MAC table. MAC table, it maps the physical address to the corresponding ports so that it can check whether a packet can be either dropped or it can be taken to the next device. So this is the main advantages of your bridges, which is used for the MAC table. The MAC table here is the strengthening point of your bridges. So next one will be your switches. So this switch is also termed as a layer 2 device. So which is a layer 2 which is nothing but your data link level layer. So this one, it is of a better performance than your bridges. So what does this switch do means? So this allocates a unique port number. So the switch contains a lot many ports. So according to the manufacturers, the switch might contain the number of ports, and this allocates what each port is decided for, and so in such a way that it removes the traffic occurring in the network. So when allocating the unique port, I can avoid my data traffic in my network. So the next one is that it has some buffer place to hold the frames. So actually the switch can be termed as a traffic cops of a simple LAN. So what is the work of the cops? To check, to monitor. So the same way your switch does. So the next one will be your router. So I have forgot to mention the layers here. So it can either be used in your physical layer as a combination with your data link layer as well as in your network layer. So next one, going to the router. So router, where do we use? Especially in the network layer. So it is also termed as your layer 3 device. So this router possesses a table called the routing table. So in the bridge or in the switch, we have MAC table, and here we have a routing table which has all the parameters like your source and destination and the next hop you have to visit and the cost, which means the distance and the time, etc. So the routing table has all these attributes. So the routing protocols involved in this layer. So we have already discussed what are all the routing protocols involved in this network layer. So these will be responsible for updating this routing table each and every second when a data arrives. So in this way, the traffic can be reduced. So these are all the characteristics of your router. So the final one will be the gateway. So coming to the gateway, so normally if I tell a gateway, it means that I must have some entry point and I must have some exit point. So same in your network, whenever your data goes out or the data comes in, so there must be a gateway in between the two networks. So in this case, the gateway is not the separate thing, but we take one of the connecting devices, that is your router, and I convert that as my gateway, which act as a central point between the two networks of entry and the exit point. So that is about the gateway. So here in a network, so the router can act as a gateway, or I can also tell my firewall to act as a gateway, Yes, so whatever the data is coming in or whether it is going out, it must go through this. So, or I can make my server itself as a gateway. So, this is the meaning of your gateway, which is your entry point and exit point. So, these are all about your connecting devices that are involved in your network. So, with this, our first unit gets over. So, from the next video, we'll start with the second unit, which covers the deepest portion of the data link layer. Thank you.